So now let's look at the second example that deals with elastic collisions moving in one dimension along the x-axis. So, an object with a mass of 0.5 kilograms is moving east with a positive velocity of 5.0 meters per second and collides with another object of mass 1.1 kilogram that is initially stationary, so it's at rest. We want to find the velocities of the two objects after they collide. So we're assuming that an elastic collision takes place between this object M1 and this object M2, where M2 is stationary, M1 is moving in the east in a positive direction. So we begin with the following two equations. So we have two unknowns, and that means we need two equations. So this equation, the first equation, comes from the fact that momentum is conserved. So initial momentum, m1 times v1 plus m2 times v2, is equal to the final momentum. So m1 times the final velocity of v1, v prime, and m2 times v2 prime, where v2 prime is simply the final velocity of object m2. The second equation comes from before. We derived this equation in the lecture where I dealt with the introduction to elastic collision. So we basically take the second equation and rearrange the equation. We bring everything to this side and leave our v prime 2 on this side, so on the right. In other words, we want to take this v2 prime and plug it into this part. Why? Well, because we want an expression that has exactly one unknown where everything else is known. So at the end we can solve for that unknown. And I want to solve for v1 prime. So we know that v2 prime from this equation is equal to v1 plus v1 prime minus v2. So I take this whole thing and plug it into v2 prime in my first equation. And I get this whole guy here, where now I have everything the same, except now I have m2 times this whole guy here. So now I multiply out by distributing, and I get this guy here. So at the end, we have m2 v1 plus m2 v1 prime minus m2 v2. And now I basically want to bring everything to this side and only leave my v1 prime on the right side. And I do exactly that, and I get this whole equation. Now notice that v2, right, our initial velocity of object 2 is 0. So anything with a v2 term will cancel out because it has a value of 0. So v2 is 0, so this guy cancels out. And v2 here is 0, so this guy cancels out. And we are simply left with m1 times v1 minus m2 times v1 divided by m1 plus m2. So we simply plug in our values and we get negative 1.875 meters per second. So that means our object m1 moves with a velocity, with a final velocity in this direction, in the west direction, with a magnitude of 1.875 meters per second. Now, in order to find my velocity of m2, I go back to one of my equations, to this equation, because now I know this guy, so I only have one unknown, namely this guy. I know this, but I don't know this. So I basically plug in this guy, and v2 is 0. So I simply get the following result. Since v2 is 0, this guy cancels out, and we are simply left with v1 plus v1 prime equals v2 prime. So I plug in my values, making sure I take into consideration the fact that v1 prime is negative. So 5 meters per second for our initial velocity of object 1, plus minus 1.875 meters per second for my final velocity of object 1. So I subtract these guys and I get 3.125 meters per second. So my object number 2 with mass 2 is traveling in the east direction with a velocity of 3.125. So before the collision, my object number 2 with mass 2 is stationary, while object number 1 with mass 1 is moving in the east direction. After they collide, this object begins moving in this direction, but this object bounces back in the opposite direction because its mass is less than this guy's mass. And that's exactly what we find.